Hey guys, tonight we begin in the dark. Not just the kind outside your window, but the kind that flickers just behind your eyelids where dreams begin. You're sitting cross-legged at the mouth of a cave, a tiny fire crackling at your feet, the smoke curling into the night like a restless thought. The stars above you are crisp and countless, and somewhere deeper in the cave, someone is painting on the walls. Just don't try living in this era if you still use shampoo. So before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And if you're still awake enough, leave a comment with your current time and location. It's always lovely to see where in the world you're listening from. Now dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You're reclining under the sky in ancient Babylon. The year doesn't matter. The time here is more sand than stone, more drift than direction. Above you, the moon is full, hanging low like a coin on a velvet string. It's steady, predictable. But if you were one of the priest astronomers of this place, you'd know better than to trust it. These early sky watchers didn't just stargaze. They watched with purpose, with trembling styluses poised to scratch tiny cuneiform marks into tablets. Warnings, observations, desperate calculations. One of their greatest fears? That the moon might one night disappear and not come back. You lie next to one of them now, shoulder to shoulder on the roof of a ziggurat, warm wind tugging at your robes. He points upward and murmurs in Akkadian, voice barely above a hum. The moon is late. Not missing, not gone, just late. But in a sky believed to be a message board from the gods, lateness could mean wrath. A disruption in the lunar pattern meant a breach in divine order. And if the heavens fell out of rhythm, so too might the world below. Tonight, the moon is delayed by clouds, but he doesn't know that. So he chews his lip, thinking of kings, crops, and floods, of enemies across rivers and omens carved into liver-shaped clay models. Because in Babylon, the moon wasn't just a light in the sky, it was the eye of the gods. And if it blinked, something down here was bound to break. Some nights, when it truly vanished, a new moon night or during a faint eclipse, the people would respond with ritual, fires, chants. They'd bang on bronze pots to scare away whatever spirit might be eating it. Imagine that. People keeping time by lunar light, terrified that the very clock they relied on might be swallowed whole. You roll onto your side on the rooftop. A dog barks in the far distance. The stars keep blinking, uncaring. But somewhere in your gut, you understand the anxiety. When you rely on something to always be there, light, breath, a familiar face, even a momentary absence can feel like the edge of the world. The Babylonians were astonishing in their precision. They tracked lunar cycles over generations, noting patterns, flaws, and the occasional surprise. The first known lunar eclipse record dates back over 2,500 years. But even as their charts grew more complex, the fear never really went away. That's something we often forget in modern science. How long fear traveled with knowledge like a shadow just behind the candlelight. Even when they predicted eclipses correctly, Babylonian scribes still wrote them down as omens of doom. The moon vanishing wasn't just math, it was meaning. Some researchers today think their records were so accurate that they noticed tiny irregularities in the moon's orbit. They might have known, or at least suspected, that it wasn't always moving exactly the same way. A hint maybe of the wobble we'll explore later. But they didn't think in terms of physics, they thought in stories. And the moon story back then was moody, divine, and full of danger. Tonight the air grows cooler. You hear the soft footfalls of priests returning to their chambers, their clay tablets tucked under their arms like bedtime books. The moon finally peeks through the haze, soft and silver. The man beside you lets out a breath he didn't know he was holding. Returned, he says with a nod, but his tone isn't triumphant, it's cautious. Like someone who's just spotted a missing cat but isn't sure if it will run again. That's how it begins, this long, slow fear that the moon might vanish for good. The first page in a 3,000-year tale of lunar insecurity, of cultures around the globe whispering to themselves, what if it doesn't come back this time? And in this rooftop silence, under this ancient sky, you start to wonder the same. The moon, it turns out, has always had a flair for drama. You're drifting now gently into a different place in time, somewhere near the banks of the Nile, or maybe farther east past the Indus Valley, or even on a hill overlooking a Mayan temple. It's a warm night. The air hums with insects, and the people around you, gente, men, women, children, are looking up with wide eyes and mouths slightly open, because the moon is vanishing. It begins slowly, like a bite taken out of a perfect circle, a curve, then a crescent, then a deepening shadow. No clouds, no warning, just darkness creeping across the face of the moon like spilled ink. You feel it in your stomach, a tug, not fear exactly, but something ancient and heavy, the echo of a fear passed down in blood. The moon, your soft, glowing night companion, is being swallowed, and no one knows why. The eclipse myths come tumbling back now, soft as feathers, sharp as flint. In China, they said a dragon was devouring the moon. In India, it was Rahu, a severed demon head, forever chasing the sun and moon across the sky. The Vikings believed wolves were trying to eat it, the same ones destined to chase the sun during Ragnarok. And in parts of South America, the story went that the moon had been wounded by a jaguar. All of them agreed on one thing: this wasn't good. You sit in the dust with a small crowd as people begin banging drums, ringing bells, shouting at the sky. Some shoot arrows upward. Others rattle bones or throw water. Anything to scare the darkness away. Because if the moon disappears and doesn't come back, what else might follow it into the void? Even in ancient Greece, where philosophers like Anaxagoras and Aristarchus toyed with more rational explanations, the fear lingered. Aristotle believed the earth cast its shadow on the moon, which is more or less true, but his explanation didn't comfort many. The thought of Earth blocking the moon's light still felt like the world turning on itself. And in the background of all this, astrology, the belief that the heavens weren't just decorative but directive, that a lunar eclipse could signal a king's death or the rise of a plague or an invasion from across the sea. If the moon disappeared from your sky, your world could disappear too. In crops, in order, in hope. You remember something odd as you sit in this imagined crowd. During a lunar eclipse, the moon doesn't actually vanish. It turns red, a dark rust-colored orb hanging low like a blood orange warning sign. And that somehow made it worse. A black sky might be blamed on clouds, but a glowing red moon, that was clearly unnatural. A few moments pass. You notice a man beside you pressing his forehead to the ground. He's muttering something, maybe a prayer, maybe a wish. Nearby, a child starts to cry. Her mother lifts her, whispering something soothing about the moon being tired, needing a nap. And just when the darkness deepens to its peak, just when silence takes hold, the light returns. Bit by bit, the moon reemerges. The shadow shrinks. The familiar silver gleam comes back into the night like a secret being slowly revealed. The relief is collective. You feel shoulders unclench, breath returns. Somewhere, a goat bleats and everyone laughs, a little too loudly, a little too long. Laughter after fear always sounds like that. But even though the moon is back, the questions linger. Why did it leave? What made it return? Will it do it again? You lie back and close your eyes for a moment, feeling the heat of the ground beneath you. The scientific explanation, Earth shadow, orbital alignment, predictable cycles, is waiting for you in the centuries ahead. But tonight, the explanation is still wrapped in myth and magic. You are part of a sky where the divine and the astronomical haven't yet split into separate languages. Some astronomers of the ancient world, like those in Mesopotamia, actually predicted eclipses. Their tables and cycles were astonishing in their accuracy, but they rarely told the people. Imagine holding the knowledge that the moon would vanish on a particular night and choosing not to reveal it, either to maintain power or simply because people didn't want logic. They wanted meaning. There's a light breeze now, and with it comes the smell of wood smoke and fig leaves. The crowd is dispersing. The moon, full once more, glows benignly as if it had never disappeared. You hear someone say it will happen again, and someone else reply, then we'll be ready next time. But of course they won't be, because no matter how many times you see the moon vanish, it always feels like a small betrayal, like waking to find your favorite constellation missing or a familiar song suddenly out of tune. And so the fear lingers. It's buried now beneath layers of story and soot and the ticking of water clocks, but it's still there, humming faintly like static under a lullaby. You open your eyes and the moon is there. For now, you're floating now, slowly, gently, across the Mediterranean, your body half draped in moonlight, half in shadow. Time has crept forward like ivy over stone, and you find yourself in the streets of Alexandria. It's late, quiet. Somewhere, a cat slinks past the foot of a column. You're standing outside the great library, and though it's closed for the night, its walls still hum with curiosity. Inside, scrolls are packed like memories into every crevice. Knowledge is growing here, leaf by leaf. But even in this place of logic and letters, the moon still raises questions no one can quite answer. One of the names whispered in these corridors is Hipparchus, an astronomer, mathematician, and chronic observer of things that most people would never think to question. You're with him now, crouched beside a low bronze instrument that looks like a cross between a sundial and a pasta strainer. He doesn't talk much, but his eyes flick constantly toward the sky. Tonight he's watching the moon's orbit, and it's not behaving as expected. Hipparchus had noticed something odd. When you track the moon across months and years, it doesn't move in a perfect circle. It speeds up, slows down, shifts slightly off course. It wobbles like a record that's not quite seated right. The word he used for this, anomaly. You sit beside him, trying not to sneeze in the dusty air, and trace the moon's path with your finger. Back and forth, sometimes too fast, sometimes too slow. This was for Hipparchus a deep mystery, one that disturbed the delicate gears of celestial mechanics. Later, Kepler and Newton would give it new names: elliptical orbit, gravitational perturbation. But here in the flickering torchlight of the 2nd century BCE, it's just a cosmic inconvenience, a reminder that even the moon, so seemingly faithful, has irregular moods. To understand this anomaly, Hipparchus turned to eclipses. He used them like calibration points, tiny resets in the moon's story. He compared records from Babylon with what he saw now, centuries later. And what he found wasn't comforting. The moon wasn't just wobbly, it was unpredictable. He tried to fix it with math, circles upon circles, epicycles, geometric models that stacked like spinning plates. If the moon didn't move how it should, then maybe space itself had hidden gears. He never quite solved it. But in trying, he laid the groundwork for 1,000 years of sky charting. You can feel his frustration in the chalk dust on his robes, in the tightness of his jaw. He isn't afraid of the moon disappearing. Not like the priests of Babylon. He's afraid of being wrong, of missing something crucial in the equations. That, for him, is the real danger. This idea that the moon could deviate from expected paths is quietly revolutionary. It suggests the heavens aren't perfect, that motion isn't always smooth or divine or predictable. Sometimes the moon just misbehaves. And not everyone was comfortable with that. You walk now through the cloisters of the library, your fingers brushing the spines of scrolls. The air smells of beeswax and ink. There's a debate happening in one of the alcoves. You can hear the words echo. The heavens are eternal. The moon is constant. A pause. Then why does it shift? Some argued that it was illusion, a trick of distance. Others suspected interference from invisible spheres. Still others suggested that our measurements were flawed. A humbling idea. Maybe the moon wasn't wrong, maybe we were. This small, persistent wobble would ripple forward through time, drawing in Copernicus, Galileo, Newton. They all took turns trying to explain it. And centuries later, NASA would send up satellites to measure it with inch-level precision. But back here, it was just a question written in chalk, whispered into scrolls, and inked beside lunar tables. You glance up. The moon tonight is glowing calmly, but now you know better. You know it doesn't move in a circle or even an oval. Its orbit is more like a spirograph drawn by a very tired god. Hipparchus sighs beside you. It'll take more than a lifetime, he mutters, not to you, but to the sky. And he's right. The moon's motion is too large, too slow, too stubborn for one life to chart. But that didn't stop anyone from trying. Because the thing about boring mysteries, the quiet ones, the ones that don't explode or scream, is that they stay, they wait, they lure you in with silence. You sit back watching a moth flirt with the torchlight. Somewhere deep in the stacks, a scroll curls ever so slightly with the warmth. And up above, the moon, delicate, deceptive, keeps wobbling toward another night. You're dozing gently now, the rhythm of history like a rocking boat beneath you. And when your eyes open again, you're in Baghdad, the air thick with rosewater and lamp smoke, stars stitched into the velvet sky. It's the golden age of Islamic astronomy. Around you are curved rooftops and the hush of scholars writing through the night. You're sitting cross-legged in an observatory which looks less like a laboratory and more like a prayer garden. Wide arches, lattice screens, and an enormous brass armillary sphere that catches moonlight like a halo. You're here with Albatani. He's known in the Latin West as Albategnius, which sounds like a wizard from a children's book. But really, he's just a meticulous man with an eye for patterns and a deep suspicion of everything that Aristotle said. Tonight, he's explaining to a scribe how the moon does not obey the rules the Greeks assigned it. Its path is irregular, not because of divine intervention, but because the Greeks got their numbers wrong. You listen as he talks about the moon's second anomaly, a sort of bonus wobble. It's not just that the moon's orbit is elliptical. It also does this little shimmy like a dancer changing tempo mid-step. Some call it the evection. It shifts the timing and size of eclipses, and it drove astronomers absolutely bananas. Albatani didn't invent this anomaly, but he documented it more accurately than anyone before him, with a kind of poetic precision. His lunar tables improved predictions. His models leaned away from Ptolemaic cycles and towards something closer to elliptical motion, a subtle but powerful rebellion. You watch as he uses a shadow stick, a long rod mounted vertically in the ground, to measure the moon's height in the sky. He notes the time, then adjusts a wax cord stretched across a carved diagram on the floor. It's quiet work, but charged with something sacred. As though by tracking the moon more closely, he's not just correcting the stars, he's correcting history. The idea that the moon could change course, even slightly, wasn't just mathematical. It had consequences. In this world, calendars were lunar. Worship, planting, tax collection, pilgrimages, all depended on the moon showing up when expected. If it didn't, or if it was miscalculated by even a day, entire communities could be thrown into confusion. Albatani's work helped clarify these schedules. But more than that, he showed that the moon wasn't misbehaving, it was just complicated. And complexity, he insisted, wasn't a flaw, it was a feature. You sit with that thought for a while, listening to the distant sound of a prayer call, soft and slow. Somewhere nearby, a child recites planetary names in Arabic, some of which will still be used 1,000 years later by NASA engineers. Albatani believed that the moon didn't just orbit, it oscillated, subtly, delicately. These shifts were too faint to notice with the naked eye. But once you started tracking them, well, the moon became a bit like a friend who says they'll meet you at noon, but always arrives 5 minutes early and acts like you were late. Still, there's beauty in that unpredictability. One of Albatani's most lasting contributions was a set of refined values for the length of the solar year and the moon's motion. Values so precise, they outlasted Ptolemy's. His observations, taken without telescopes, were accurate to within a few arc minutes. That's like predicting when the moon will rise using only a pencil and a very determined frown. You stretch your legs, wincing a bit. The stone floor isn't exactly ergonomic. The scribe nods off briefly, his quill still in hand, and Albatani lets him rest. The moon is moving slowly tonight, like it knows someone is watching and doesn't want to be caught rushing. There's something soothing about this kind of obsession. The kind that says, the world is confusing, yes, but if you watch it closely enough, it will make sense. Or at least, sense adjacent. You glance up again. The moon is round, full, bright, but you know now that beneath that glow is a layered choreography of gravitational tugs, tiny corrections, and quiet defiance. It isn't misbehaving. It's just moving through a more complicated universe than anyone expected. And so are you. You're waking into a new century now, or maybe you never fully slept. The air feels colder, damper, edged with coal smoke and ink. You're standing in a narrow corridor lined with brass and mahogany. The year is 1676, and the moon's mystery has just entered its mechanical age. Welcome to the Royal Greenwich Observatory. A bell tolls somewhere. You blink and rub your eyes, realizing you've stepped into the domain of John Flamsteed, England's first astronomer royal, a man with a wig so large it might need its own orbit. He's hunched over a desk littered with lunar tables, drawing lines that curve ever so slightly. They're maps of frustration, really. The moon refuses to match the predictions again. And Flamsteed, for all his obsessive cataloging, cannot make it behave. You sit beside him, your breath visible in the chilly room, and watch as he mutters about the inelegance of lunar motion. It's supposed to follow rules, strict Newtonian rules now, but instead it staggers like a tipsy aristocrat. No matter how many times he adjusts the calculations, there's always a lag, a lead, a tilt. By this time, Newton's theory of gravity has just started to reshape the universe. You'd think this would solve everything, right? Well, not quite. The moon's orbit turns out to be the perfect test case for Newton's math, too perfect in fact. When Flamsteed plugged in the known laws of motion and gravity, the predictions didn't match reality. Not exactly. There was still that slippage. Those stubborn seconds of error that showed up in eclipse forecasts and drove astronomers mildly insane. Flamsteed, ever the data hoarder, began a campaign of obsessive observation. He recorded the moon's position night after night for years, hoping the numbers would eventually click into place. Sometimes they did, sometimes they didn't. He blamed the instruments, then the air, then himself. You peer through his telescope, a long, clunky tube mounted on a creaking wooden scaffold. The moon floats there like a smudged pearl, distant and quiet. Beautiful, yes, but also slippery. You know now that what you're seeing isn't the full story, that beneath that round glow is a gravitational argument still being had. The real trouble was this: Newton's laws mostly explained the moon's orbit, but not entirely. And that mostly drove everyone up the wall. It suggested the moon was being influenced by something else, something subtle. Maybe the sun? That was one theory. Maybe the Earth's own shape, and its slight bulge at the equator, was tugging on the moon like a mischievous younger sibling. Some of Flamsteed's colleagues began proposing corrections. Edmund Halley, yes, the comet guy, suggested the moon's acceleration was slowly increasing over centuries. A terrifying thought if you're trying to predict its position 100 years from now. Others whispered even stranger ideas, that space might have drag, or that time itself wasn't entirely uniform. These were early, vague stabs in the dark, but they hinted at a larger truth. The moon isn't just orbiting Earth. It's orbiting Earth while Earth is orbiting the sun, and being tugged this way and that by countless invisible threads. You lean back against the wall as a young assistant brings in hot tea. It smells of cloves and tin. Flamsteed barely notices. He's still sketching, still trying. You admire him for it. not because he solved the mystery, but because he refused to pretend it wasn't there. That's what makes these early scientists oddly comforting. They didn't need to be right. They just needed to be honest about being wrong. You trace one of his drawings with your finger. It's a looped spiral, like the moon is dancing around Earth while Earth races forward, which is exactly what's happening. It's like trying to model a ballerina pirouetting on a galloping horse. No wonder the numbers don't line up perfectly. Outside, the night has thickened. London's lamps glow through the fog like distant stars. You can almost hear the moon laughing softly above, not mockingly, just amused, like it enjoys the attention. Back in the observatory, Flamsteed sighs and sets down his pen. You don't say anything. You don't need to. You're starting to understand the deeper truth. The moon was never supposed to be easy. If it were, we wouldn't still be chasing it. We wouldn't still be watching. It vanishes behind a cloud, and you wait quietly, patiently, for it to return. The cloud passes, and the moon returns, faint at first, then confident, gliding across the sky like it owns the place. You're not in London anymore. You're somewhere colder, windier, the kind of cold that sharpens your breath and turns eyelashes into frost. It's the 1740s, and you're in Lapland, or close enough, bundled in a fur-lined coat that smells like pine and ink. You're here with a French expedition, knee-deep in snow and surrounded by sled dogs that look smarter than most philosophers. The moon watches from above as you and a team of geodesists, yes, that's a real job, prepare to measure the shape of the Earth. The goal? To prove that Earth is not a perfect sphere, but slightly flattened at the poles. A prediction made by Isaac Newton, and still at this point controversial. You're helping check that by charting how long it takes the moon to cross the sky at different latitudes. Why the moon? Because it's a kind of cosmic tape measure. Its apparent speed and position change depending on your location. Subtly, yes, but enough to detect. And this brings us to a new anxiety. What if the moon vanishes not in the sky, but in mathematics? See, there's a problem. The more precise astronomers try to be, the less cooperative the moon becomes. Its motion is affected not just by the Earth and Sun, but also by small irregularities in the Earth's surface, in air pressure, in timing equipment. These little things pile up, and suddenly, you're not sure if the moon is misbehaving or if your math is. The team in Lapland is meticulous. They haul long iron chains across snow to measure baselines. They check angles with quadrants so large you have to climb onto a ladder to use them. They compare lunar positions over weeks of biting cold, recording every flutter and flicker. Some nights the moon seems to arrive late. Other times it's exactly where expected, which is somehow more suspicious. You and the others begin to suspect it's mocking you. But then, in a flash of sleep-deprived clarity, someone proposes a new idea. What if the moon never repeats its orbit? Not really, not perfectly. What if it follows a path that's quasi-periodic, almost repeating but never exactly the same? A kind of cosmic jazz improvisation, looping themes, but always with a new twist. This concept doesn't have a name yet, but it's the seed of something big. Chaos theory. The moon, it turns out, might be the most stable, unstable object we know. Locked in orbit, predictable enough to set calendars by, yet constantly flirting with disorder. Back in Lapland, your team finally finishes its measurements. The Earth is indeed squashed, just a little, and Newton gets a posthumous high five. But the moon? It remains mysterious. You imagine someone in Paris reading your field notes by candlelight frowning. The moon's path curves, loops, tightens, then relaxes, like it's breathing or dreaming. And here's a wild thought. Maybe the moon is dreaming. Maybe this whole orbit thing is less like clockwork and more like sleepwalking. The indigenous Sami people nearby have their own beliefs about the moon. They say it's alive and doesn't like to be stared at too long. They avoid pointing at it. They treat it like a shy spirit, visible but private. It's not science exactly, but there's a strange kind of respect in that. A knowing humility that says we don't need to measure everything to understand it. You sit on a log by a fire, your boots steaming. Someone passes round reindeer stew. The moon rises again, full and pale as paper, casting long blue shadows across the snow. And you realize something, it hasn't vanished. It never really does. It just keeps dancing, slightly offbeat, just far enough to stay interesting. You lean back, sighing, your breath curling upward like a ribbon. And above you, the moon keeps watch, silent, tilted, beautiful. You've drifted now, gently, into the 19th century, the age of polished brass and velvet chairs, where science starts dressing itself in tweed and formal letters. You're seated in the Paris Observatory, and the air smells of old paper, star charts, and coffee that's been reheated one too many times. The moon is high again, not just in the sky, but in public imagination. Poets write about it, lovers swear by it, and astronomers, they're still frustrated. But now there's a new player in this dance of lunar confusion, Pierre-Simon Laplace. His name already sounds like a sleepy lullaby. Laplace was the kind of person who could take Newton's gravity and twist it into something sleeker, a mathematical symphony called celestial mechanics. He believed quite passionately that if you just knew the position and velocity of every particle in the universe, you could predict everything forever. Cause and effect wrapped up in numbers. No surprises, no chaos, a moon that obeys. But even Laplace had to admit the moon didn't quite follow this perfect script. So he spent decades developing an enormous system of equations to describe every gravitational tug, the moon's motion influenced not just by Earth and Sun, but by the other planets, even by Jupiter, from 800 million kilometers away. It was the equivalent of trying to balance a giant mobile where every wire sways every other. And still, the moon didn't sit still. You flip through one of Laplace's manuscripts. The handwriting is tiny and impeccable, like it was done by a clockmaker's ghost. Each formula tries to bend the universe into predictability. Laplace was certain the moon wouldn't vanish, not physically, not mathematically, but he also acknowledged something unnerving. Even the most perfect system can produce results that feel random. This is where the cracks in certainty begin to show. As the century rolls on, other scientists pick up the thread. One, an American named George Darwin, yes, Charles Darwin's son, suggests something radical. What if the moon used to be part of Earth? He imagines a primordial Earth spinning so fast that a chunk of it flung off and formed the moon. It's not quite correct, but it's the beginning of a new way to think about our companion, not just as a traveler, but as a twin. It explains in part why the moon doesn't quite follow the neat orbital paths expected. It's not just orbiting, it's reacting to tides, to Earth's wobble, to old scars of a shared violent past. You stand now in the observatory's dome, peering through a telescope larger than a horse-drawn carriage. The moon hangs there, cratered and calm. But behind that calm is motion, always motion. Every 18.6 years, its orbit wobbles slightly in a cycle called the lunar nodal precession. Every month it speeds up and slows down just a little. These are not flaws in the machinery, they are the machinery. And yet even now, predictions sometimes miss by minutes. The moon arrives early or late. It shifts its tilt. It toys with eclipses like a magician slipping a coin behind your ear. Some astronomers joke softly that the moon has moods. Others, more seriously, begin to question whether long-term lunar predictions are even possible, whether chaos might be baked into the system itself. You lean against the railing, letting the telescope's brass rim press coolly against your forehead. You hear the gentle ticking of the observatory clock behind you, and for a moment you don't want an answer, you just want to watch. The moon doesn't need to make sense to be real. You imagine the future, where probes might land on it and people might walk on it and still not fully understand it, the same way you might know a friend's face so well, but never quite predict their dreams. The moon lingers above, pale and precise, but inside that precision is something gloriously unpredictable. And tonight, that's enough. The moon follows you now into the 20th century, an era of ticking Geiger counters and humming cathode tubes. You're in a lab that smells like ozone and soldered wires. The wallpaper might be peeling, but the brains in this room are brand new. It's the 1920s, and science is going through its rebellious teen phase. Quantum mechanics is making a mess of determinism, and relativity is bending the universe like taffy. But tonight we're keeping things classic. You're revisiting the moon, still full of mystery, still reluctant to be understood. This time, though, the focus isn't on the moon's orbit, it's on its effect. You're in a dusty room with Wilhelm Schuster, a German physicist who's convinced the moon is messing with Earth's magnetic field. He has data, long rolls of numbers recorded from observatories across the globe, and he swears he sees a pattern. At first, you squint at the graphs and see nothing, just noise, wiggles. But after hours of staring like a magic eye painting, something emerges. Tiny pulses in the geomagnetic field that seem to align with the moon's position. Schuster isn't alone. A few British scientists joined the hunt, positing that the moon might tug not just on oceans, but on air, on electric charges, maybe even on time itself. Some of them start speculating that lunar cycles could subtly affect everything. Animal behavior, seed germination, even stock prices. You chuckle gently because, of course, it sounds ridiculous, but the numbers are there, or at least they seem to be. And this raises a deliciously boring scientific debate. What counts as real influence? The tides, yes, obviously. The moon pulls on the oceans, stretches them slightly, makes them rise and fall like the chest of a sleeping giant. That part's solid, but can it really stretch our brains, nudge our sleep patterns, whisper into the magnetosphere? Some say yes, others say that's just old folklore dressed in lab coats. Meanwhile, new tools are making everything harder and easier at once. Computers, room-sized, humming, clunky beasts, begin crunching lunar motion with greater precision than ever before. You sit beside one the size of a wardrobe, feeding it punch cards while it calculates the moon's next 1,000 orbits. And what do you find? Errors. Tiny, stubborn ones. Seconds off, then minutes. The moon, again, doesn't quite match the predictions. Even with all the math, all the inputs, it slips the leash. It moves with a rhythm that seems almost intentional, as if it's resisting capture. This is when the word perturbation becomes a favorite. It means a small nudge, a gravitational tickle from some other body. But it also feels emotional. The moon is perturbed, unsettled, maybe even shy. You step outside into the cool night air, the sky is clear, and there it is again. Full, round, and almost smug. You wonder what it knows that you don't. Somewhere in California, a young scientist named Richard Feynman is teaching his students that nature's laws are like a chess game. If you observe long enough, you might figure out the rules. But what if, you wonder, the moon isn't playing chess? What if it's improvising? By the 1960s, the moon becomes less theory and more target. Rockets aim at it. Astronauts train to land on it. But before we get to boots on the ground, scientists have one last trick up their sleeve: lasers. In 1962, a laser beam is fired at the moon, not to destroy it, just to bounce back. The idea is to measure the exact distance between Earth and moon with insane precision, and it works. But even then, the data shows something strange. The moon is slowly drifting away, not fast, just a few centimeters per year, like a friend backing out of a room inch by inch without saying goodbye. It's still here, of course, but it's leaving very, very slowly. And somehow that's worse than vanishing. You look up at it again, and for the first time you wonder if it misses us too, or if it's relieved, free of our measuring tapes, our chalkboard equations, our endless questions. Maybe the moon, like all good mysteries, just wants to be left alone for a bit. And maybe, just maybe, that's why we love it. Now the world tilts into the 1970s, and the moon is no longer just a blurry circle in a telescope. You've touched it? Well, not you, exactly, but your species has. There are boot prints in lunar dust, a flag that refuses to wave, and inside NASA's mission logs, millions of numbers showing exactly or almost exactly where the moon should be. You're in a darkened control room, lit only by monitors and cigarette tips. On the screens, telemetry data, orbital plots, and grainy images of a place that was, Until recently, only poetic. This is the age of laser retroreflectors, tiny mirrored panels left on the moon's surface by Apollo astronauts. From Earth, scientists fire laser beams up into the night sky and wait for them to bounce back, measuring the time it takes to return. The result? An absurdly precise measurement of the distance between Earth and Moon, to the millimeter. And with that precision comes a quiet panic, because the moon is still drifting away, about 3.8 centimeters per year to be exact. Not a lot, but when you run the numbers backward, you hit a wall. If the moon's been drifting at that rate forever, it would have been inside Earth just 1.5 billion years ago. But we know, or we think we know, that the moon is older than that, maybe 4 to 5 billion years. So scientists start debating, loudly, sleep-deprived, and caffeinated. Some argue the drift wasn't always this fast, that early Earth had a thicker atmosphere, more drag, more tidal friction. Others say the data is off, or that something big and deeply unaccounted for happened long ago to kickstart the moon's departure. There's a quiet hum in the lab. You glance at a chalkboard filled with squiggled equations, arrows pointing everywhere. One formula catches your eye. It relates to the moon's libration, the slight wobble that lets us see about 59% of its surface over time, rather than just 5%. It's hypnotic, this subtle dance, a slow nodding, a gentle no. Even from 4,400 kilometers away, the moon seems to have moods. And then an unexpected voice joins the conversation, oceanographers. Because as it turns out, to understand the moon's motion, you need to understand Earth's tides. Not just in the water, but in the mantle. That's right. The Earth itself bulges and breathes ever so slightly in response to the moon's pull. These deformations cause friction, and that friction transfers energy. It's like dancing with someone who steps just a little off beat. Eventually they pull away. This friction slows Earth's rotation. Days are getting longer by about 1.7 milliseconds per century. Not enough to notice unless you're immortal, or a pendulum, or a computer trying to predict lunar motion a million years into the past. Now you're in a meeting room with planetary geologists and dynamical theorists arguing over coffee. One camp is waving a paper about tidal acceleration. Another is scowling at a graph that refuses to line up with lunar eclipse records from ancient Babylon. The moon isn't just drifting. It's telling conflicting stories. It's like a witness in a cosmic mystery who keeps changing its testimony just enough to make you doubt. There's also something haunting about those old eclipse records. Some are surprisingly accurate. Observers 2,000 years ago writing down the exact moment the moon swallowed the sun. But when you try to plug those timings into modern orbital models, the moon sometimes shows up a few hundred kilometers off. Too far for comfort, too far to blame on scribal error. So a few theorists, possibly a little too tired, start whispering about chaos theory again, about how a system with enough moving parts, Earth, moon, sun, tides, core, might never be fully predictable. Not because the math isn't good, but because the math isn't enough. The moon, they suggest, might be part of a system that looks stable, but flirts with instability over long stretches of time, like a balancing act that wobbles once every million years or so. You lean back in your chair staring at the ceiling tiles. One tile has a stain that looks vaguely like a crater. You imagine it's Copernicus or maybe Tycho, the big ones. Then you imagine standing there on that surface, looking back at Earth, watching the clouds swirl, the continents blink, the tides shift. From up there, you'd never guess we're worried, that we've spent centuries scribbling and scratching our heads, wondering if you're leaving us or just plain hard to get. Maybe the moon is still waiting for us to stop asking what it's doing and start listening to how it moves. You glance again at the laser log. The numbers are exact, but the meanings are not. And somewhere inside that contradiction, that tension between what's measured and what's understood, the mystery grows deeper. You close your eyes. The moon is out there, still drifting, still reflecting, still resisting the neat closure of an equation. And isn't that what makes it beautiful? By now you're deep in it. Not just the night, but the mystery. The moon is no longer just a cold rock in space. It's a reluctant subject in a very long and very quiet interrogation. And tonight you're in a university basement that smells faintly of chalk, coffee, and existential dread. On the projector screen, a graph that looks like static. But a professor with too much hair and not enough sleep swears it's the lunar recession rate. How quickly the moon is gliding away from Earth. The line isn't smooth. It has jagged dips, tiny cliffs. Someone asks if it's an error. The professor shakes his head slowly and whispers, "It's real. We just don't know why." You settle into your chair, arms folded, watching the discussion unfold. One student raises the idea of Earth expansion. Maybe the planet is swelling like a sponge, shifting the moon's path. Another suggests ancient volcanic events. A third, bless their optimism, says, what if the moon is alive? Nobody laughs, because at this point, almost anything sounds possible. But tonight's story takes a more terrestrial turn. You follow a trail of obscure papers from the 1980s, when a strange discrepancy began haunting geophysicists. They'd run long-term simulations of the Earth-Moon system and get results that didn't match historical eclipse records. Again, always the eclipses. You travel to an old library with creaky floors and dusty shelves. There, in fragile volumes bound with cracked leather, you read about solar eclipses recorded by Chinese astronomers in 720 BCE, Babylonian priests in 136 CE, and Arabic scholars in the 900s. The times and locations match up astonishingly well, which is a problem, because the models say the moon shouldn't have been visible in those spots. So either the moon used to move differently, or time itself has stretched. One hypothesis emerges like a half-remembered dream, that Earth's rotation hasn't slowed evenly. Maybe it hit speed bumps, periods of faster or slower deceleration, caused by seismic activity, ocean current shifts, or mantle viscosity changes. In other words, the planet breathes unevenly. Another theory blames core mantle coupling, the idea that Earth's molten core occasionally grips the mantle more tightly, adjusting rotational speed in unpredictable jerks. It's like a vinyl record skipping a beat mid-song, throwing off the timing of the whole dance. But then comes the strangest idea of all, that some of the ancient records are too good, that maybe the scribes recorded something they couldn't possibly have seen unless the moon used to orbit slightly closer or tilted on a slightly different plane. This suggestion sparks one of the quietest academic feuds in history. Journals filled with footnotes like tiny jabs. One scholar writes that his rival's model is impressively imaginative. Another replies that the criticism overlooks basic celestial mechanics, perhaps intentionally. You can almost hear the clinking of teacups between the lines. And then you find a journal article that changes everything, or at least shifts the tone. It's by a team of French geophysicists who propose a reconciliation, that a combination of tidal drag, glacial rebound, and ocean basin realignment might account for the lunar timing discrepancies over millennia. You exhale relief, maybe, because even if we still don't fully understand the moon's past, we're getting better at predicting its future. Laser retroreflectors, still bouncing signals back from the Apollo era, continue to narrow the margins. High-precision GPS, gravitational mapping, and lunar reconnaissance satellites now provide absurdly detailed data. Yet despite all this, the mystery isn't solved. It's just smaller, like a polished stone in your pocket. You can't quite explain why it feels important, but it does. Back in the lab, the professor has replaced the projector slide. It's a new graph, this one showing the Earth-Moon distance 600 million years ago. A red line curves downward, steep and aggressive. Back then, the moon orbited much closer. Days were only 21 hours long. Tides were terrifying. Life had just emerged from the sea. One student murmurs, "That's when the moon was young." You blink, it's true. And as you sit there, you realize we're not watching the moon age. We're growing old together. You step outside again. The air smells like wet pavement and fallen leaves above you. The moon is half full but whole in its presence. It's not hiding. It's not gone. It's just further. Maybe that's all vanishing ever really is. Not disappearance, just distance. Some nights you can't stop thinking about the things we almost knew. You're lying back on the floor of your living room now, a blanket beneath you, the lights dimmed to a soft amber glow. Outside the window, the moon is visible, pale, watchful, and a little smug. It knows you've been following it for hours, maybe lifetimes. Tonight's thread unravels from a question scientists once thought they'd answered. Where did the moon come from? Sounds like a simple enough query, but you're in for a ride through the wildest of celestial detective stories, one where every clue points somewhere else. For a long time, there were three main suspects. Capture theory, the idea that the moon formed somewhere else and got lassoed by Earth's gravity like a runaway horse. Co-formation theory, that Earth and moon formed together in the same primordial swirl of dust. Fission theory, the moon was flung off the Earth, maybe from a spinning molten blob that couldn't hold itself together. You picture a cosmic centrifuge flinging a chunk of itself into orbit. Dramatic, messy, very cinematic. But none of these fit perfectly. The moon's orbit, composition, and spin didn't quite match the stories these theories told. Then in the 1970s, a fourth idea emerged, stronger and bolder than the rest. The giant impact hypothesis. It proposes that a Mars-sized object, usually named Theia, collided with Earth about 4.5 billion years ago. The impact vaporized part of both bodies, and the leftover debris coalesced into what we now call the moon. You blink at the idea that the moon is Earth's ghost, or its twin, or maybe its scar. But again, things don't line up neatly. Lunar rocks brought back by the Apollo missions show isotopic signatures nearly identical to Earth's mantle. Too similar, really, if the moon was born partly of another planet. If Theia came from somewhere else in the solar system, its chemical fingerprint should stand out. But it doesn't. It's like comparing handwriting and finding your own. So theorists begin revising again. Maybe the impact was so violent that it completely mixed the materials. Maybe Theia came from a nearby orbit and had a nearly identical composition to Earth. Or maybe, and this one feels like a whispered bedtime riddle, Theia wasn't another body at all. Maybe Earth hit itself. A glancing blow, a gravitational self-spasm, some strange dance of orbital mechanics that tore a chunk loose from its own crust. It sounds absurd, but then again, you've been talking to a drifting satellite for hours. Later, researchers simulate impact scenarios on supercomputers. They run thousands of variations. Fast collisions, slow ones, head-on impacts, oblique grazes. The results produce dozens of possible moons, different sizes, speeds, and tilt angles. The moon, it turns out, is a statistical winner in a cosmic lottery of crashes. And here's the most haunting detail. We might not be alone in this. Saturn's moons, some show signs of similar impact-borne origins. Pluto and Charon, a binary planet pair formed possibly from a great strike. The universe, it seems, is full of wreckage that turned beautiful. But nothing lasts forever. You roll onto your side and consider this. Even now, the moon's orbit isn't perfectly stable. It's tilted, eccentric, wobbly. Some simulations show that billions of years from now, the moon might drift far enough to loosen Earth's tides, slow its spin to a crawl, and unbalance the seasons. Life might shift again or fade, but not tonight. Tonight, the moon is still tethered, still watching, still spinning stories across the sky. And you're tracing those stories backward, hoping to catch a glimpse of something long gone. Not a fact, but a feeling. A flicker of understanding, like seeing your own reflection in a pool of still water just before a breeze ripples across the surface. That's what science often is. Not certainty, but movement. Not answers, but orbits. And sometimes the most boring mysteries are just old ones that never got resolved. You close your eyes and let the idea drift. The moon, a leftover from a colossal crash, a silent partner in Earth's most ancient trauma, quietly circling us as we sleep, never quite leaving, but also never quite still. There's something comforting about repetition. The soft tick of a clock, the circular path of the moon, the way your own thoughts keep looping back no matter how far you drift. It's a rhythm, familiar, quiet, a lullaby written in planetary motion. Tonight, you're returning to the moon again. Not its origin, not its retreat, but its wobble. Yes, wobble. Technically called libration, though that word makes it sound far more elegant than it looks. Imagine someone trying to keep perfect balance on a slackline while wearing two big shoes. That's the moon from Earth's perspective. And because of this wobble, you can actually see about 59% of the moon's surface over time, not just the expected 50%. It's as if the moon is slowly turning its head, giving you a slightly larger peak, but never the whole thing, never enough to see what's behind. Somewhere deep in the 18th century, astronomers first noticed this subtle shifting, not through high-powered telescopes, but with paper, ink, and absurd levels of patience. They sketched the moon's face again and again, mapping the slight oscillations. Peaks that would disappear one month and return the next, a crater's shadow shifting ever so slightly, like a stage actor whispering lines behind a curtain. You're sitting now in an old observatory dome, the air thick with the smell of machine oil and books. The telescope is pointed skyward, unmoving. Someone left a cup of tea beside it, long cold, but the machine still hums with purpose. A young astronomer in a wool cardigan explains how libration isn't just poetic, it's also practical. These wobbles helped early scientists triangulate the moon's shape and orbit, help them realize the moon isn't a perfect sphere but a lumpy ellipsoid, slightly stretched from centuries of tidal locking. And here's where it gets strange again. That tidal locking, where one side of the moon always faces Earth, isn't some fixed eternal thing. It's dynamic. It had to settle into place. Early in its history, the moon spun much faster, but Earth's gravitational pull acted like a brake, slowing it down over eons. The friction created heat. The heat softened rock, and eventually the moon's spin matched its orbit. The same face, always watching. It's why we call it the near side, not the front, not the top, the near side, a label born of longing, not geometry. But for centuries, nobody knew what lay beyond. The far side, not dark, despite what Pink Floyd would have you believe, rotates in sunlight just like any other. But it remained hidden until 1959, when a Soviet probe named Luna 3 finally sent back blurry black and white photos. The first time humanity laid eyes on the moon's mystery face. And what they found? Cratered, jagged, strangely quiet. The far side lacks the vast lava plains, Maria, that we see on our side. Scientists still argue why. Some say it's due to crust thickness, others suggest impact angles, but nobody's quite sure. One theory even speculates that early Earth's gravitational pull kept the near side hotter for longer, making it more volcanically active. It's as if our side of the moon changed simply because it was looking at us. You pause there, a rock shaped by attention. That's the kind of thought that follows you into dreams. Back in the observatory, the young astronomer runs a simulation. On screen, the moon dances slightly, a barely perceptible sway. You watch it spin and halt, always returning to the same face, like a child playing hide and seek who never quite leaves the corner. Then she clicks one more setting. Suddenly, the simulation shows what would happen if the moon weren't tidally locked. It spins freely, showing all sides. A complete rotation every few days. You feel a strange sense of loss. The familiar face is gone. The man in the moon becomes just another cratered stranger. And yet, part of you is curious. If we'd grown up with a rotating moon, would we still have written as many poems about it? Would it feel more like a companion or less? One thing's certain, the moon we know is a moon shaped by restraint, a moon sculpted by gravity's soft grip. And that grip, it's still shifting. Lunar laser ranging, the bouncing of light beams off mirrors left by Apollo missions, confirms tiny ongoing changes in the moon's rotation and orbit. Microscopic variations, sure, but they add up. The moon is still wobbling, still adjusting, still trying to decide how best to be seen. Kind of like you. So tonight, as you lie there in the dark, think about the slow sway of the moon. Its awkward grace, its refusal to show you everything at once. And know that even the most distant things have a rhythm, a pulse, a tilt. Even the moon doesn't quite know how to stand still. You've probably heard this before. The moon controls the tides. It's one of those facts you pick up early, somewhere between learning how to skip stones and discovering that magnets are somehow both normal and magical. But tonight, you're diving deeper, beneath the waves, beneath the metaphors, because the moon isn't just tugging at oceans, it's shaping time. You're back on the shore, barefoot in the cool sand. The tide is low and little rivulets are carving wiggly paths back to the sea. Overhead, the moon hangs like a white paper lantern illuminating secrets that are mostly water and gravity. Let's start simple. The moon pulls on Earth, not hard enough to yank anything off the surface, just enough to stretch it a bit. Water responds first because it's fluid, and we see that as high tide. But Earth itself deforms too, ever so slightly. Even the land has tides. Mountains lean a millimeter toward the moon, then ease back like tired dancers. The moon pulls on the oceans, yes, but it's not alone. The sun does too, about half as much. When both align, we get spring tides, higher highs and lower lows. When they're at right angles, we get neap tides, gentler shifts. It's a three-body ballet, Earth, moon, and sun, with oceans as the stage curtains. But here's where it gets delightfully weird. These tidal effects aren't symmetrical. Water bulges on the side facing the moon, but also on the opposite side. Thanks to inertia, the Earth spins beneath these bulges. And because of friction, again with that sneaky culprit, the tidal bulge is always a bit ahead of the moon's exact position in the sky. That offset creates torque, a tiny celestial shove. The result? Earth's rotation slows down. Not dramatically, just by about 1.7 milliseconds per century. But it adds up. 1 billion years ago, a day was only 18 hours long. Think about that, entire sunsets that arrived too soon, early protozoa staying up too late, maybe. Meanwhile, as Earth slows, the moon is pushed outward. It's spiraling away at about 3.8 centimeters a year. We know this thanks to retroreflectors placed on the lunar surface during Apollo missions. Scientists bounce lasers off them. Yes, really. And measure the delay. The moon's drifting, slowly escaping like a teenager inching toward the door while pretending to still listen. And just like that, we stumble into one of the most bittersweet facts in science. There was a perfect moment, a fleeting period, maybe around 400 million years ago, when the moon appeared just the right size in the sky to perfectly cover the sun during a total solar eclipse. That's only possible because of a cosmic coincidence. The sun is 400 times larger than the moon, but also about 400 times farther away. It means the moon can cast a shadow that kisses the Earth with surgical precision, a total eclipse. But as the moon drifts away, that alignment won't last. In some distant future, no more perfect eclipses, just partials, shadows with frayed edges, cosmic memories. Some paleontologists think the moon's influence may have helped complex life emerge. The regular rhythm of tides created intertidal zones, environments that are constantly wet, then dry, then wet again. Perfect for early evolution experiments. Some creatures learned to hold their breath, others learned to crawl. Tidal pools were like scientific petri dishes, but on a planetary scale, a place for legs to invent themselves. Even today, some marine animals synchronize their behavior with the lunar cycle. Corals spawn during full moons. Grunion fish surf the waves to lay eggs in wet sand, perfectly timed with tides. And humans? Some believe we still carry that rhythm inside. A lunar pull on our sleep, our moods, even childbirth rates. The evidence is murky, Studies contradict one another, but the myth persists. Maybe because it feels nice to believe that something as distant as the moon still matters here. You lie back on the shore and close your eyes. The tide is coming in, slowly, predictably, like a story that's been told for billions of years and still hasn't lost its rhythm. And somewhere deep inside, a clock ticks in watery increments, seconds stretched by salt. You're floating now, not in water, but in thought, drifting in that in-between place where science feels like folklore and facts feel like dreams. It's fitting because tonight's mystery is both old and new, the moon's strange influence over insomnia. You've probably heard the rumor that people sleep worse during a full moon. That lunacy, from luna, Latin for moon, was a real medical concern, that wolves aren't the only ones howling at it. But is any of that actually true? You're lying in a quiet bedroom now, the curtains gently swaying. A full moon paints silver streaks across the floorboards. Outside all seems calm. Inside your thoughts are a little too awake. Ancient cultures certainly believed in the moon's effect on minds and moods. The Greeks blamed Artemis for erratic dreams. In medieval Europe, sleepwalkers were said to be moon-touched. And 18th century asylum records show a spike in patient agitation during the full moon, though that might have had more to do with moonlight keeping them awake than mystical forces. Science didn't pay much attention to this claim until recently. For decades, sleep research focused on circadian rhythms tied to sunlight. But in the last 20 years, a few curious scientists decided to revisit the old lunar theory, not with legends, but sleep labs. One famous study in 2013, conducted almost as an afterthought, found that people slept 20 minutes less during the full moon. They took longer to fall asleep and had reduced deep sleep. The lab had no windows, no clocks, no knowledge of the moon's phase, and yet the pattern appeared. Cue headlines: "The moon messes with your sleep." But follow-up studies haven't always found the same result. Some show a tiny effect. Others, none at all. Meta-analyses remain conflicted. Still, something odd lingers in the data. Sleep irregularities during the full moon appear stronger in people who are naturally light sleepers. There may even be a sex-based difference. Some researchers report women show more noticeable changes. One theory suggests evolutionary roots, that early humans might have been more alert on moonlit nights when predators or rival groups were more active. In other words, the moon didn't make us crazy, it made us careful. You're walking now through an ancient village, thatched roofs, firelight flickering, no artificial lights, no digital clocks, just the slow arc of the sky. On moonlit nights, the world is brighter. People stay awake longer. Children squint toward the forest's edge. And maybe that's it. The moon once signaled danger, or at least opportunity. More time to hunt. More risk of being hunted. Our ancestors might have tuned their sleep not to comfort, but to caution. Even today, studies in communities without electricity show clearer lunar sleep cycles. Not just shorter sleep during full moons, but a pattern that starts building a few days before, as if the brain senses the change in sky brightness before it fully arrives. It's not just sleep either. Some hospitals report mild increases in ER visits during full moons. Crime rates, too, have been rumored to fluctuate, though again the data is inconsistent and often exaggerated. Police departments occasionally prepare for busy nights, but mostly out of tradition. What's most curious, though, is how stubborn the belief is. Moon-linked mood swings appear in cultures across continents. There's even a psychological term for it: illusory correlation. When people see patterns that aren't statistically sound, but feel deeply real. And let's be honest, full moons are hard to ignore. They're luminous, still, suspiciously unblinking. There's something about their timing, how they rise at sunset and set at sunrise, opposite the sun, brightening the whole night. No wonder they're lodged in myth and language. Moony lovers, lunatic whims. Even the calendar quietly obeys. Month comes from moonth. You shift under the covers now. The fan hums softly. Outside, the moonlight glows against your window pane. Maybe tonight you'll sleep a little lighter. Maybe not. But one thing's certain, whether it tugs at tides or tugs at your dreams, the moon has always had a presence just slightly larger than physics can fully explain. It's not just a rock. It's a ritual, a silver cue that something's stirring, out there or in you. And even if the science doesn't fully agree, even if the graphs come back inconclusive, the moon still feels like it's watching. Just a little. You're walking in slow circles now, not pacing, just orbiting gently around a question that's lingered since the beginning. What if the moon disappeared? Not in the poetic sense, not clouded or eclipsed, gone. Let's say it winked out like a light bulb finally giving up the ghost. No bang, no farewell, just absence. The night sky would feel immediately off. Your body wouldn't know why. Something quiet would be missing from the rhythm. But soon, the real changes would begin. First, the tides. Without the moon, the sun would still tug at Earth's oceans, but only half as effectively. That means lower highs, weaker lows, and gentler tidal currents. Intertidal ecosystems would collapse. Species that depend on tidal timing, crabs, mollusks, nesting birds, would lose their ancient clock. Then, the Earth's tilt. Right now, the moon acts like a kind of stabilizer, a gravitational anchor. It helps keep Earth's axial tilt relatively steady, about 23.5 degrees. Without it, our tilt could start to wobble wildly over millennia. Some models suggest Earth's tilt might swing between 10 and 85 degrees. That would be catastrophic for seasons. You could have tropical summers in Antarctica followed by darkness that lasts for years. Civilization, if it even survived the transition, would be unrecognizable. The moon, you realize, is not just scenery, it's climate insurance. But it gets stranger. If the moon had never existed, life might never have emerged as it did. The moon's creation, likely from a Mars-sized body, smashing into early Earth, gave us not only tides, but a reformed Earth, one with a molten surface, a sped-up spin, and a dense iron core. That impact also tilted our axis, creating seasons. It may have even delivered essential ingredients for life, or carbon, water, maybe even amino acids. The moon is a fossil of our most violent beginning, and simultaneously a gentle regulator of everything since. But here's the odd part. We don't really understand how rare this Moon-Earth combo is. Among the thousands of exoplanets discovered, moons are difficult to detect. We know of some, large ones orbiting gas giants, but none quite like ours. A moon that is 1/4 the diameter of its planet. Proportionally, that's huge. Most moons are specks compared to their hosts. Our moon is more of a companion, a co-orbiter, a planetary sidekick with seniority, and that matters for habitability. Some astrobiologists now argue that stable axial tilt and moderate tides might be prerequisites for complex life. In other words, if you want frogs and forests and bedtime podcasts, you might need a moon like ours. You're sitting under a tree now, perhaps a eucalyptus or a slow-moving pine. The moon's light spills down through the branches like milk over shadow. And you wonder, how many other moons are out there, silently setting the stage for consciousness? Because without ours, we wouldn't be here to ask the question. No night walks, no werewolf stories, no lunar landings, no quiet sighs at the sight of a full moon from a kitchen window, just a dimmer sky and a colder Earth. And yet, here's the kicker. The moon is still leaving. Remember the retreat? 3.8 centimeters per year. Someday, it'll be too far away to cause total eclipses. Someday the tides will weaken. Earth's spin will slow. Billions of years from now, days will stretch toward the unbearable. Maybe 40 hours long, maybe more. The moon is not eternal, but it lasts longer than memory. And maybe that's why we keep whispering about it, writing poems, naming months, using it to frame our questions about love and loss and why we sometimes can't sleep. The moon keeps time, not with ticking seconds, but with phases, pulls, and possibility. You followed it through cold observatories and tidal shores, through sleepy villages and scientific debates. You've seen its shadow cast across ancient stone and modern paper. You've watched it fade from superstition to satellite target, and back again into something nearly mystical. It's more than a rock. It's the narrator of night, the keeper of subtle forces, the boring mystery that never quite lets go. And now the moon is high, still, pale, patient. You've wandered far tonight, from Babylonian clay tablets to lunar landings, from forgotten fears to strange experiments with tides, time, and sleep. You've watched astronomers squint at it with trembling hands. You've stood in places where people thought it might vanish or crack or whisper secret instructions to the ocean. But now you're just lying here, breathing slowly, listening to the soft hum of the world around you. Nothing left to learn for now, just the weightless drift of understanding, the comfort of knowing that even the strangest ideas, that the moon causes madness, or that it saved us from cosmic chaos, once felt perfectly reasonable. Still do, in a way. You might start to forget the details soon. The moon dragons, the tidal clocks, the wobbling earth. That's okay. Let it all wash away like footprints on a quiet shore. What remains is something deeper, a rhythm, a pull. The sense that you're part of a story far older than cities and far softer than science usually dares to be. The moon will be there tomorrow night. Maybe it's full. Maybe it's gone. Maybe it's hiding behind clouds and doesn't care if you remember its name. But you will, because deep down, some part of you, a quiet dreaming part, still feels the tug, still looks up, still wonders.